Welcome back to Maven Spire's Brief History of Storage webinar. No, I jest. We're talking about modern storage, and if you joined us for our last episode, we were talking about block storage. Now, just a few reminders. Why are we talking about storage? Storage is the place where your information lives. It's the memory of your business. It's the data that makes you competitive. It's also the data that you action off of. We are in the intelligence revolution, AI being part of that. And so it's not about the raw data you collected, it's what we can learn from it and what actions you can take from it. The other thing that I just want to remind everyone of is that, in case you haven't noticed, we never shrink storage-wise. Like the people making storage go through just all sorts of miracles to try to get more density of storage into a smaller package. But they don't do that because you're buying less storage. They do it because people are buying obscene amounts of storage, more and more every year. And we needed to get it down from warehouse size to rack size to even be able to approach that. So if you ever wondered why in data centers 5 years ago it was super innovative to have a megawatt of power per rack, that was really a storage thing. Now when people have megawatts per rack, now it's an AI compute thing, ironically. But I'm sure we'll be up to 5 megawatts per rack, and then it will be a compute and storage thing very soon. So just keep in mind that the definition of what is fast and what is dense changes pretty much every week. And this is why we're having this lovely conversation about storage. So as I mentioned, our first episode was about block storage. We wanted to talk about the fundamentals that are used to upkeep virtualization, databases. So if you're all about that kind of thing, you should go watch part 1. Today, we're going to focus on unstructured storage. Now, I do get the question all the time, what is unstructured storage? And the bottom line is it is for storage with things that don't have structure. I know, I just repeated the word back to you in a different order. But truthfully, file servers, objects, streams, think about it this way. When somebody asks you to go through a file server to find a picture of yourself 10 years ago, if it was structured, it would be super easy because you would click on a button and it would bring up that picture for you. Because it has no structure, that's why you have to sort through folders and go looking for it. And the same is true of any unstructured data type, whether it be medical research or e-discovery or making a motion picture or just having your files on a server. Whenever you want to go find something, something has to crawl through to find it. It does not have structure. So we're going to do that. And then our next episode will be about backups, objects, and cloud. Oh my, right? So come back and we'll talk about secondary storage, what that even means, and where things like S3 and cloud play in to the whole storage gambit. Now, if you tuned into episode 1, you know that my partner in crime for this little adventure is Butch Kraken. He's with Arrow, so he sees a lot of different technology. And like me, he's been doing this an awful long time. So we try really hard not to remember what it was like when we started and dive into those rabbit holes. We'll try to spare you as much as possible. But just remember, when you're talking about storage, when you're talking about everything, the goal is to focus on the problem you're trying to solve and not the solution you think will do it. When you believe in a solution above all things, you sometimes miss solving the problem. And so this session and all of the sessions we do is about giving you the information so that you can kind of tease out the parts of the problems and challenges you're facing and give you a leg up in trying to find an action plan to deal with them. So with that much, I will drop my share so that you can have yours.
Oh my goodness. I can't believe it's only been a week since we last talked, Michael.
I know, right?
It seems like only yesterday, and now we're back in here and we're talking about something I think we both love. Unstructured data is like, the fun is part of the job because, like you say, everybody's got it, and it's growing. When I talk about the definition of unstructured data to my family, I'm reminded of the times we get together as a family and we take a photo and we take a few photos and we have neighbors or people in the restaurant. They take group photos of us as well. We take our selfies. And as soon as we take the big picture of everyone in the group, someone from the group was missing and they have to come in and take more photos. And we take two or three of those. That's unstructured data and it's growing. So I think,
Right.
I'm at risk. I think I'm contributing to this story. So here's what I'm saying. We're going to talk about something that I'm extremely familiar with, very comfortable talking about, and I'd like to see what your thoughts are, and how other people are using unstructured to really solve real world problems, not just my camera on my phone kinds of problems. I think Dell got a head start on this thing. And what I love about the head start was they started off with building something that would be multilingual in a multi protocol way. What does that mean? Being able to build out something that could talk to different applications, all using the same data, using different languages so that we could apply all types of thought processes from emails, databases, et cetera, into the same databases. And so this has been going on for quite some time. It keeps on growing, but it becomes more relevant as we think about you know data lakes, life scientists, media and entertainment, all types of applications for what we're calling this unstructured data. I'd like to start off really just kind of by showing like how one of the Dell clients is using this to solve a real world problems.
When we look at AI is the tip of the iceberg, but you need a whole foundation underneath it to support it, make it sing, and make it do what you want. Maya HTT, we deliver engineering, manufacturing, and industrial operations solutions for our end clients. MDA Space has been a long-term Maya HTT client, and they build and manufacture satellites. They're solving an amazing problem, which is connecting worlds that are unconnected on the planet. They have hundreds and thousands of documents of unstructured text and information, but the challenge is to access it in a really easy and fast way. We were really looking at the ecosystem and the architecture, and Dell PowerScale became a natural fit with the NVIDIA GPUs to run the LLMs and feed that information back. We created the MBOT solution that essentially harnesses that data. Finding the right information in that time span is really accelerating the pace of production and enabling MDA Space to go from one satellite every couple of weeks to multiple satellites per day. The AI solutions that MyHTT is developing really connect unconnected people around the globe, but also on the ocean with marine vessels, moving goods in a reliable and eco-friendly fashion. CSL is a large operator of marine vessels around the planet. One of the biggest challenges that we were trying to address with CSL was to harness the terabytes of telemetry data that they are generating every year. Dell PowerScale really enabled that our AI models run real fast despite the immensity and the terabytes of data that are feeding the models. AI-powered predictive maintenance help maintain peak efficiency. We're talking about 3% energy savings over long periods of time. When we look at CSL and the real-time telemetry, a big element is situational awareness, key to the safety and security of the crew first. The secondary benefit was reduced risk of whales being hit or being injured by very large vessels. As we look to the future with Dell Technologies and NVIDIA, they will continue to enable us to drive a real-time feedback and insight to our client, an AI ecosystem, which is really exciting on all levels.
Okay, I was gonna say something about you inserting a video to do it and stuff. I was thinking back to what is that, Mystery 9000 kind of deal, and I have to say, okay, you picked something visually stunning. There were some really pretty frames in there. you kind of hit the whole, hey, AI is an unstructured problem in a video. I hear you, right? And you prove that people actually use the stuff in ways that can save the whales, which is very Star Trek of you. So, kudos for the video, even though like I was giving you some side eye on that one.
Well, I had to find a way to wrap all that up really quickly and say, this is important stuff. There's going to be some slides that start to pull all this together. But when you see it in the real world as an opener, it's an eye opener to say, all of these things are real world problems that didn't really exist long before this. We gained some capabilities, and this helps us to really grow into an area that wasn't there before. But we're solving real life enterprise problems, and the problems that are being solved around different workflows include things like data access, the quality of that access, the challenges that you see with the infrastructure, with capacity growing, with performance. You've talked about that. It also includes compliance and regulatory components, and sometimes legal components that might be factored into what you're building out. And then there's always security, making sure that we're supporting ransomware support. All of these things, inclusive of that, is understanding how to build out and grow infrastructure that is easy for AI people who manage and monitor that to actually build it out and maintain it. So the skill gap for AI is an area that people are looking at as well. So, this is all on the table again for a storage product. You're like, okay, how did we get here so quickly? we were just a moment talking about what unstructured data was. Well, we talked about all the different things that you could do as far as looking at where unstructured data comes from, right? And then understanding some of the use cases, whether it's business intelligence or data lakes. And now you can see where the products from Dell at the bottom, the power scale, the object scale, fit as a solution to support all of this. And then, as you look at this slide and realize that this is the mindset, or this is kind of these are the drivers, I guess, for the folks that are building out these unstructured data solutions, knowing that it has to be available to support everything. And so this is a simplified way of going like, wow, it's a big problem, and we have a way of solving for it, and it's being used quite a bit. So
I think I saw that slide like 5 years ago, and
Mhm.
it wasn't called the AI data platform. It was called like the data lake platform. And it was almost the same problem, right? You have these big data applications that are doing analysis, and then you have some sort of compute thing going on where you need to be able to get into the raw data, process it, and spit back out processed data. And then you have to like archive data, and you have to do it all in a very seamless way. And I remember the use case back then was, I think it was Hadoop, where they were talking about how having the multi-protocol side of the power scale meant that you could reach in with HDFS to get straight to the data and process it, and then spit it back either as S3 or NFS to the same device, right? And so you saved like 8 to 10 hours for every time you had to do a run, because you didn't have to copy it and then process it. You just would come back to the same source to make it go. And I think it's sort of interesting that here we are later, that same model is going on, but now it's for AI.
You're right. And the difference maker is that, Dell is really putting a wrapper around what they're calling these data engines. So a data processing engine, an unstructured data engine is planned. AI data pipelines are planned. These are data engines that will be branded Dell, that will have certain capabilities. So we talked about earlier about giving intelligence in front of the array where your storage is, and this is driving that same solution. So nothing's wasted in this world. I've come to believe everything that we've done in the past, it comes back up in a different format, but you hit it right on. This is interesting. A lot of folks are saying, we've talked about a couple of things, power scale and object scale, as far as, what are they really, and we'll kind of go into like what they are, how they're different, because, folks say these are both components of the unstructured data solution, and I like to differentiate them in this way. The power scale is the multilingual solution that, talks all languages, kind of can be data anywhere, to support any application. Very performant, very well trained, and it's one file system for whatever you want to lay out there. Object scale comes in on the other side of that. It's designed really for the S3 communications. And while it can do some things multi-protocol if necessary, it's really stronger for the newer solutions, for the container-based solutions, for things that need performance from an object perspective. They really solve in the unstructured both sides of the equation. And we're excited to see like how object scale is being put in place because it's really primarily where if you're going to do 95% of your conversation is S3, it's a great fit. Both powerful, both scalable, both secure. All of those things are incredibly important, but it takes on like its older brother the efficiency and the ease of management, and that's really the advantage there. So I would say let's look at the kind of the unstructured storage and get the benefits out, and we're kind of going back into rolling back to that front slide and looking at something that you just talked about, Michael, Hadoop. When that was all the rage and everybody was leaning in, going like, "Hey, these things can talk different protocols, different languages." When I took my second new hire, I went out to Seattle and spent a week, and I got a chance to work with the Isilon team back in that day. And what I was amazed at was the tenacity they had with being able to take a user with particular capabilities, criteria, and give them access to data from a number of different types of shares, whether it's SMB, whether it was FTP, normal shares, all of it looked and felt like you could just reach out and touch the data. And they were able to put guardrails in place and put in all the security. And that was back in the day. This has continued to grow. And now you look at the OneFS and you're like, wow, this is everything, including the integration of ransomware protection. And we've talked to Superna as far as some of the things that they're doing from a data protection standpoint. I even had a conversation this week with Pearl Lion and how they're integrating major security improvements with the way this thing rolls out the door. I continue to be in awe of just how partnerships are growing and how long this particular solution has really helped out. And then I look at the plans for this, which I'll talk about in a bit, and think about where the entire world is going from an unstructured standpoint, and knowing that the roadmap that we're on is going to blow everyone's mind. OneFS, to me, it's just a common conversation. It is one file system, and it is basically the underneath everything that you would want a platform to do, this file system can do. Everything from the multi-protocol access that we've emphasized to Sync IQ, to snapshots, Smart Connect, to now metadata IQ and being able to find data with an elastic search across multiple nodes, across different geographies, et cetera. Smart lock, smart quotas were things that were always there, part of this solution. But as you look at this scale out and build out, those key features have always been there. Now you layer that operating system onto a Dell server, and that's where the real growth starts to happen. So this is PowerScale providing unmatched enterprise services with all of that multi-protocol, all of that flexibility built in. The idea is you bring your application to the data, not the other way around. This really plays a great part when you think about your data being in the cloud or being on-prem in a hybrid environment, and understanding I don't have to move my data to different locations to get a certain effect. I can basically plan and build a solution that will support all of that. So when I think about object scale, again, at the center of that, I get S3 and all of the different things that it can bring from the standpoint of different areas, from dev test all the way into the syncs and shares and the analytics and the things that people are writing now for a lot of the cloud-based solutions. I can have that working for me on-prem as well. And so this is the best-in-class object storage, and it's essential to realize that all the benefits of AI we're taking into consideration from what we've learned with PowerScale now available, as the way that we think about rolling out Dell Object Scale. So it's combining storage with the power of AI data platform and allowing organizations to kind of modernize their strategy, and prepare for everything AI driven. Object scale is powerful. It's very performant, same tenets that we talk about, but it brings together the best of what we've done from an innovation standpoint and gives you back a trusted ECS foundation for huge scale out in this area in this architecture. What I miss on that, Mike?
I don't know. You did a lot. Although I have to ask this question. I know this is like, now I'm just messing with you kind of stuff. But so when you add metadata IQ, is it actually unstructured at that point? Like if you actually bring structured, unstructured data and then export it to Elastic, I mean, isn't that actually the definition of semi-structured data at that point?
Yeah, you start to think about it. Is the smarter your metadata becomes, the more structured your solution becomes. Now, the metadata is going to change, based on what you need and how fast you access everything and what you need it for. But you think about the intelligence of what's being pulled by an application via metadata, and if you can improve the performance of how metadata works, you can improve the performance on these two arrays. And that's what, when I talk with Dell about the future, it is really their performance improvements are really around, the way their optimization is going on the software that includes all the metadata that points to all this stuff. So yeah,
I
which is
remember
faster.
I remember a
Yeah.
couple of years ago, in the genomics industry, people were struggling with how to get unstructured data arrays to like help them do the work. And they were introducing applications on top of the storage, which was adding metadata, where basically you have like a DNA strand like stored in its full
Hmm.
form,
Yeah.
but you use metadata to be able to code out the ones that are interesting for the pieces of the strand that are interesting for the problem you're trying to solve. So instead of
Yes.
seeking the entire file, you only seek the parts that are interesting in the data, and you cut the time to do the work down infinitesimally. Sounds like what's happening is, instead of it being an application on top, it seems like for unstructured, it's coming into the device now, where
Right.
intelligence is now living in the array to be able to semi-structure the stuff and speed it up. Not from a like traditional storage point of view, but I know what you're querying, I know what you're trying to do, and now I give you what you need.
Yeah. And this is the better alliance, the better together, where everyone had really considered that these types of solutions, that these types of questions would be taking place at the compute level, not at the storage level, where like, no, I can actually feed you the data. I can pre-pick and fill cache with the data that I think you're going to need next. It's a complementary solution, and these appliances do a great job of giving you a build out of something that's going to be long term, great solutions that you can build out for a lot of things. Oh man, data lakehouse. We talked about it earlier, still in there. But you think about this, ECS coming on object scale. ECS was the software that object scale was based on, and then building out the turnkey appliance that gives you back this type of capability. Um, you know, Being used in all types of different industries, and it's continuing to grow. It's got its own built-in backup, disaster recovery, and globally accessible namespace, and data governance also out of the box with this solution. That's object scale. So you can drive AI innovations faster with PowerScale. It's the world's fastest Ethernet based appliance, certified again with NVIDIA's DGX SuperPod. Lots of documentation, lots of thought leadership with how that's put out there. But the PowerScale delivers a range of features that really sometimes don't get their full credit. Part of that is the GPU Direct. That's it. That's being able for the GPU direct storage to access the storage directly at a higher speed. Very efficient. NVMe all flash. We talk about that as a storage component. That's all a part of that as well. So you get with that the low latency. From a software perspective, you get from the Isilon family the file locking and all the exceptional things that we did from a performance standpoint with Isilon. Again, all of this stuff rolls back into that. and you get concurrent multi-file writes and high performance write throughput with this system. It includes checkpointing, and everything is built into that thing. These systems, the newer systems, are the F910, the F710, and the F210. All very performant. You can build a cluster with three of these things and grow it out as far as you can imagine. So, again, building on that same concept, you think about that with object scale. It's built to handle tough workloads. Again, very performant, massive scale with this thing. These come out in what we call a dense X560 HDD appliance and an all-flash XF960 appliance. They make a great fit for large-scale use cases. Data collection is a good use case. Model training, global content delivery, another good use case for these types of solutions. And so you'll start to see this, really start to build out, what Dell's doing. And I liked, the mindset of where Dell's going with this, because they understand that, next steps on this really are going to be how you deploy and scale it long term. How do you scale it, understanding the needs of both, where it's going to go in the cloud, et cetera. We talked about Wasabi being a part of Dell's, story with object scale, and being able to store your data on the cloud, pull it back from the cloud. It's a phenomenal better together story. We'll talk about Wasabi in our next session. But talk about, this timing could not have been better for this product and the things that we saw this year, especially with DTW and what's coming up next. So anywhere edge, the power scales, and you think about putting some of these solutions out on the edge where you can have a relatively small footprint. But edge computing overall is being able to deploy something where calculations go on external to the overall big data center and the cloud. We'll see that a lot in manufacturing. You'll see that a lot in just, safety components. You'll see it in energy. You'll see it in smart cities. Imagine being able at the edge, as an example, to look at and a picture that you're looking for people, and in that picture you have dogs, and you can recognize the two different ones. Wouldn't it be cool if you could send the face of the person back at a higher resolution than the picture of the dog for quick discovery of who's where or what's going on in the particular picture? Edge computing has a million ways that it can be used, but when you add that extra layer, then all the security and all the components that come with that go out to the edge as well, as far as what do you do. So this, again, PowerEdge gives you the flexibility to grow that thing, expand it to the edge in many use cases, including, capturing data from sensors and IoT devices. We talked about streaming, same type of thing. Streaming data is high on the list now. And this is a story where Dell continues to excel. And when doing streaming, although we've seen things come from other folks in the industry, what we're seeing from a Dell perspective is Dell does this with a very low latency. They do it with very low power requirements, and they can do it in a much smaller footprint to get the best performance. And so we lean in on, look at the performance, look at how much energy it takes for a particular use case, and understand that this is giving you the best bang for the buck.
I've noticed that in the unstructured sort of market out there's a lot of vendors who have gone to being software defined, where they don't care as much about the hardware. They're just a software product that lays on top. In Dell's case, what's been interesting to me is that a lot of their performance focused models are really just built on PowerEdge servers, right? Something they already designed for speed and capability. In the case of the power scales, I've noticed that they still custom engineer nodes for density, right? They still are able to say, hey, like if we're trying to be market leading density, then we need to custom engineer that box to be able to have more disks, more flash, more whatever to fit in a bigger Lego, right? But when like even the newest stuff, I noticed that they're already doing performance in the server line to be able to keep up with the demands of AI and liquid cooling and all of that stuff. The fact that they are also certifying it as storage appliance just makes sense, right? Why build two
Yeah.
things? If you've already made infinitely fast, just go with it. And so that's
Yeah.
kind of like, and why I said that in this particular slide moment is the server line has been used at the edge forever, right? Different
Right.
sizes and shapes to do applications in the office or on poles or on train tracks. And all
Yeah.
this means is that some of those things that are getting like zip tied on are just pure storage so that the compute has time to keep up and look, just like you were talking about, the puppy and the person. Like I'm aware that in Japan, they have smart billboards where it's
Hmm.
looking who's in the car and
Yeah.
it is like giving you ads on the billboard. Well,
Yeah.
that's happening because behind the billboard is the storage and compute to run that operation to do the match on the person and their interests and put the thing
Right.
up. You don't have time to go like to the cloud and think about it a while and come back. When you talk about
Nope.
self-driving cars, the biggest limiter right now is you need the data space that has traditionally only been in the cloud, but you don't have time. So they keep
Right.
having to pull more and more into the car, which is why we've, started making jokes like cars are really laptops on wheels and stuff, right? Because
Yes.
because they have a huge amount of storage capacity and compute just to be able to like think about driving or parking themselves.
Yes. Yes. You're 100% right, and it's only going to get deeper as we go. So edge is growing like crazy, and everybody's pushing for that.
Yep.
Um, and this is a great play for that. And you think about that, you know, still, you know, the same solution still supports what we're doing in the core. We talked about that and some of the things that are required from there, but you get into some new requirements there when you start to build it out in the core. With the, how do you balance it across and eliminate hotspots as you build it out? This solution is one where I was amazed to see in person Nokia actually build out nodes for a new solution that they built many years ago, and they actually were able to want to grow that. I sent them some systems, and they actually plugged them in over lunch, and I watched the system do the upgrade in minutes.
Yep.
And I was coming from
Yeah,
a world where you didn't do anything in minutes. Nothing took minutes, and now
Unstructured is a place where people got started building in Legos a long time ago, and
yeah,
you can't just have it. You can't have it down. It's too much data. So
yeah,
like this
yeah.
idea that you would add in the new thing and eject the old thing, and then this is how you would do refreshing with zero downtime. Like that really started in the storage universe before it moved
Yeah,
into the compute and virtualization universe. And it still
yeah.
works today. We have so many customers that are built sort of just like this with the all flash layers for the workloads that absolutely has to turn instantly and the archival nodes
Hmm.
where the data lives when it's not being, torn apart. And because of the way
Hmm.
those architectures work, you can have it spread across, which means the right data at the right speed, at the right cost, all the time.
Exactly. Exactly. And I mean, you look now at the different, it's a good lead in. Where is it going? When you think about this application, OneFS being, a part of what's in the cloud, so you do get that whole hybrid cloud environment, but you're really dealing with the same, same parameters, same way of backing up data, same way of snapshotting, the same rules that you've applied to your business, and now you can apply those across the cloud in a number of different ways to do that. So now you can have, multi-cloud adjacent, which was before a dream. Imagine if I've got data and I want a particular component of Google from a software perspective, but I needed another component from AWS to look at that data and actually, do some type of calculation in order to give me a differentiator. I've got the ability to now spread out, where that compute is coming from and get me back a solution that I can learn and love. So for PowerScale for AWS, this is giving again a number one NAS solution from our perspective to AWS, where we've got a lot of users. Now, customers can run software they trust on-prem or on public cloud, and retain all their stuff. And this gives you the ability to really, grow out and be very flexible how you want to move data. A lot of things are
Well, it
developed
also
in the
works
cloud.
with
Hmm?
data gravity, right? Like
Yeah.
you have
Oh,
people who
yeah.
are trying to make decisions about, do I move solely to the cloud so the data's in the cloud? And then what do I do about the stuff that's on-prem and how do I make the choice? Like all of
Yeah.
these features are about the answer is both. The data's in both places. You can get to it the same
Right.
way. When AWS compute is operating on it, you don't need to pay ingress, egress on that. You're just like
Yeah.
we have it in both places, and it stays in sync. So like people
Yeah.
can do what they need to do when they need to do it and from what perspective they have to do it. And that's super important because there's lots of things where, like using your surveillance example, like what we're doing with that at the edge is very security or marketing focused. But that data
Mm-hmm.
rolling up to the cloud is going to be about strategy and financial analysis, not about how do I put on something on a billboard right now. And being able to say yes to all the needs of the data is really how you drive intelligence, right? And
Yeah.
either or just doesn't get it done.
Not even close. Not even close. So you think about an infrastructure where you've got 1.6 petabytes of active data that you can spread out across this thing. And if you tier it, you can do even more with Cloud Pool. That's a lot of growth. That's a lot of flexibility. Most people don't even come close. But when necessary, you know that you've got something you can scale and grow, and you're not going to break your energy bill when you start to grow it out like that. It's really built for that. We talked about AWS. We can't leave out Microsoft Azure, and this relationship has been in place for a very long time as well. Part of that big multi-cloud story. But you think about PowerScale for Microsoft Azure, unparalleled flexibility. Organizations can balance those requirements across different clouds and get the management they're used to and expect, and also keep the controls that they have in place to support this. Data handling much more simplified because they're using tools that they're very, very familiar with. So this has got some success stories again that we could go into a longer detail, but there's a lot of clients in this space, and you can get up to 11 times the space as far as the larger namespace using this as compared to Azure. That's a big, big draw for a lot of the conversations that go into this space. So no limits. We're looking for storage that doesn't give us limits, or solutions that give us no limits, and how to build those things out. When we say object scale can scale to exabytes, we mean it. Uh, that's virtually no limit to what the enterprise can achieve. And you think of object scale scalability in a customer examples, um, single federation, 816 node cluster across 2 sites, 2.7 billion transactions a day. 50% of the site. The second customer, 256 node global cluster across 4 sites, 409,000 namespaces, users, 553,000 buckets. These are current customer examples of how they're being used. Huge, huge deployment, lots of flexibility. Um, so this is next level, definitely next level. So
I think the most amazing thing is people design products and solutions for what people actually ask them for. So
yeah,
when you look at numbers like that, billions of this and 500,000 of that, that's because it's the new table stakes. It's what everybody is,
exactly.
they're already stressing about how to get to the next level after that. So
Mm-hmm.
it's just amazing, how it grows over each year, each decade, and what people have to do to support that growth.
Mm-hmm. So this is an area where you start to stop and you go like the thought processes behind object scale and what they're doing around the relationships with Wasabi, the whole multi-cloud environment. It just it kind of removes all of the things that would keep you from growing an environment. It simplifies the whole concept. Come to the table with this many options, that kind of capability from performance, and it reemphasizes where Dell's going from a leadership perspective. It's no reason. It's a reason, really, that 250 plus industry apps and certifications and partnerships are built on these technologies. And this is the Magic Quadrant. We're all very familiar, but this is an area where we've dominated as a leader for the ninth year in a row. And we got the report available for everybody to click on that on Gartner if they wanted to actually see the reprint from this. But think about that. That was, just, it seems like just yesterday I was in that class and actually talking to the engineers about how they went about the mindset of how they built this thing out. and now to see it as a leader in the space, especially against Pure, Vast, IBM, Cumulo, this is a phenomenal thing. So
You know what the most
proud,
amazing
yeah.
thing about that slide was for me?
Mm.
So I don't know that we talked about it in this session because truthfully we talk so often. I don't know everything we say to each other or when, but people don't invest in unstructured data solutions unless they have a decent amount of data. Like there's some argument about where is that line. Some people say 100 terabytes. Some people say 50 terabytes. Some people say if it's not a petabyte, why are you talking to me? But when you look at that 16,000 customers, keep in
Yeah.
mind that all of them have a decent amount of data or they wouldn't be buying. So when you
Yeah.
multiply 16,000 by pick your average size, how much of the total space in the world is occupied
Right.
on these platforms at this time? It's just a
Yeah.
crazy number.
That's
And of course, it's
mind-boggling.
hard to calculate because you're going to pick some average number and multiply. But it's and it's
Yeah.
also really interesting to see who else is in the upper left because those are all players that are about storage. They're IBM is an old sort of old storage provider back to the mainframe sort of days, right? Pure is a very viable storage provider in the block and file place where they're trying to meet the needs of their customer. Vast is a very unstructured storage company trying to conquer the world with unbox intelligence. And Cumulo has been an unstructured sort of file, almost a software-defined play for a long time. I think it's kind of an alliance with HPE on that. All of these are people that are solving problems for big sets of data
Oh yeah.
and trying to
Absolutely.
do it with new and innovative ways. I mean, it's kind of crazy to watch how there's new problems every minute and people there to try to address them.
Yeah, that's the amazing part. To stay in that leadership role, it's my hat goes off. I think to the folks that run the R&D, the product managers, because I can't imagine what those back office conversations look like. But you leaned in on it. Lots of customers that trust this, and this is just a small fraction of some of those. One of the customers that I do love that trust this solution is one I'm kind of familiar with, and that's the McLaren Formula One team. They've used this as well as a lot of other Dell components to be a part of their solutions, and they use that because for them, getting the bestest and the fastest and tuning that car is critical for everybody that's on that team. And so they're fans of Dell. They're fans of the Power Scale, the Power Store, and they use those in a lot of different solutions. There's a full video like the one that we opened up was specific to their usages for that. It's also available on the Dell site, and I'd recommend looking at those and many other that we have from an outcomes perspective. Um, but this is one of those things where you can have all of the solutions in place. You can have all of the best case scenarios, but none of these solutions work unless you really understand the partnerships that come from the people that are on the scene. Companies like Maven's Fire that talk to the clients, that understand both the technology, the resources, the limitations, and where the best fit is for a lot of these types of solutions. And so working with a company like Maven's Fire, who's been in this game for a long time, had so much credibility, and we just love watching these clients, your clients, grow and build out solutions that are going to really be life changing. So whether it's unstructured with Power Scale and looking at the different things that we talked about today with how that solution is built out, power or object scale and how that's being built out, we feel confident that as your clients look at storage, whether it's unstructured or structured, that they're going to be in good hands. And so that at the edge of it is really all of it is really about building that trusted environment and understanding that you got the right partnership to go to market with this and build out the story. This is my summary slide for today. It's similar to the structured when I talked about the the structured storage, the block storage on last week, but this is really the telltale. This is what I'll say is, it's becoming inevitable that everyone with ambition are building out new use cases, new applications, and power scale, object scale. This full unstructured suite is the landing zone for a lot of the things that we're doing and we're seeing with AI. The future is built, not just in pixels, but in blocks. So this is the way that we're building that thing out and growing this thing to make an environment where you can dream bigger. So I want to thank the Mavens Fire team for the invite and, giving us a chance to kind of sit in the co-pilot seat with you and drive this thing.
You made me feel really old 2 slides ago. Like you had it buried in there. I don't know if you meant to, but on your little tech speed one on the 2 slides back, where you identified the size of drive and the underlying unit, and it was 122 terabyte single drive underlying it. And I flashed back for a second to the 10 megabyte hard drive that it used to take like 2 hands because it was like 40 pounds to carry around.
Yes.
And then you start just kind of tossing off on a slide this 122 terabyte single, tiny little drive that is part
Oh my
of,
goodness.
something that makes up a couple exabyte sort of storage solution. That I had to, made me catch my breath for a second there. It's not your fault,
Yeah.
but I'm just saying,
Yeah.
right?
And bigger drives
the
are coming.
pace of this industry
Yeah.
never ceases to amaze on how it can double the size of the capacity and shrink the size of the physicality in each generation. But
Yeah.
122 terabytes. Okay, I'm losing the
Yeah.
rest of the coolness because I'm stuck on the drive, right?
So true. So true.
Rich,
Man.
thank you so much for taking this time to walk through unstructured data. I think it's important to know that this used to be a very file-centric conversation for decades, and streams and object. The reason that they occupy so much of the conversation now is they are the current challenge. They are what people are writing for, the kind of data that is the challenging data. Truthfully, the stuff that's file, a lot of it is kind of baked. Like the process is baked. As long as they have equipment that can just move it faster and faster and can deal with billions of tiny little files to be able to analyze and move it in the time they need to be able to pull something off,
Yeah.
that challenge is seen as done, right? Now we're moved on to the next challenge, which, is the multiple billions of objects and stream objects and trying to keep up with that. I was actually reading an article today that some of the array makers are talking about how streams, like a continuous stream of data where it's all super important, the ability to grab, dissect, and store that when it never ends. Talking about drinking from a fire hose, right? That never ends.
Yeah. Yeah.
Is one of the hardest technical challenges that exist because there's no break. You can't design it for a buffer that then commits. It has to be steady stream, the capability to just take infinite data and process it infinitely. And that is kind of the new mountain. And that is all unstructured. That is the new unstructured mountain.
Yeah.
So
it is.
All right,
Yeah,
everyone.
This is the continuation.
I thank everyone for watching. I hope you'll come back for episode number 3. We're going to get crazy with DR and cloud and how that all works together. And I appreciate everyone's attention.